Hello learner, welcome once again to Manifested Online Classes. We are going to continue with our topic on area approximation. In this lesson, we are still going to look at further solution for questions of getting area using the trapezium rule. This is just to make it perfect. They say practice makes perfect. So in the lesson, so as the objective goes, it is further worked examples on finding area using trapezium rule. The objective is quite obvious, to give you, the learner, more experience on varied questions. So as it always goes, we always look at an example and we work it out. So I'll put down the example on the board. So there is a very good example on the board, well written. So it's always very good to go through the question before you solve it. So I read, the volume V in meters cubed and pressure P in newtons per millimeter squared for a given mass of a certain gas at a constant pressure are related by the formula P times V is equal to 20. Plot a graph of P against V and use trapezium rule with 4 equal intervals to estimate the area or under the curve by plotting values of V from 4 to 8. 4 to 8. 4 to 8. So what will guide us through the question is for us to plot those values, P against V. When they say P against V, what they start with is always on the vertical axis. It is always on the vertical axis. So the first procedure is to plot the graph. And you can't plot the graph. You should first of all get the points for the graph. So they said P against V. P against V. But when you plot the graph, it will be V that will be at the top. P against V. So it will be V at the top. So in the question, they have given you values of 4 to 8. 4 to 8. So there is 4, 5, 6, 7, and 8. So there is a connection in the formula. PV is equal to 20. That is what will help us to get P. That is what will help us to get P. Now, if V is 4, what will be P? It means, what do you multiply by 4 to get 20? If I plot that, I'll find the value for P, which represents the pressure, is 5. I'll come here again, 5. When V is 5, what will be the value of P? It will be 20 divided by the 5, and I'll get 4. Hope you are together, learner. We come to 6. When V is 6, what will be P? So you take 20 divided by 6. 20 divided by 6. 20 divided by 6, you'll get 3.33. 3.33. So actually you would have got, how do you get P? P is 20 divided by V. That's why we are coming out with those values. We are coming out with those values. Now we fit here 7. 7, it will be 20 divided by 7. 20 divided by 7, which will give us 2.86. 20 divided by 7 will give us 2.86. We come to the last one, 8. So it will be 20 divided by 8, the value of V. It will give us 2.5. So to get how you'll get that area easily and how you'll get the trapezia or the ordinates that will help you to calculate the area, it is always good to plot. So I can choose suitable intervals. I can choose suitable intervals. So I'll draw the graph. So this is 4 units, 4 to 8. So I'll draw. Start with that. So for P, the largest value is 5. So I can say largest value is 5. I can take 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you'll draw it. So just to make it more visible, you can have 1, 2, 3, 4, 5. 5. So on this one, you can just use the same scale because it's only 4 of them. Extend this one a bit. So we have 1, 2. So for this one, you can use a smaller one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've used a small one so that we easily get 4, 4 and 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, so that I easily get the values of that. So I can come and prolong this so that you get the ordinates. So it will go into our points, but it's good if we'll see the curve. So you'll come and plot your graph. When P is 4, actually the curve is actually at the top here. We have 5. When V is 4, so you'll plot this is V, volume, and this P, pressure. So we have the volume and the pressure. So we start with 4. This is 5. It's here. We come to 5. It comes to 4. Somewhere there. 6. It is 3.33. 6. It is a third of this. So it's here. 7. 2.86. Somewhere here. 2.86. And lastly, 8, 2.5. So you'll actually get your smooth curve. So it happens to go through there. So that will be a curve. So the area you are interested to get is that one. The area you are interested to get is that one. So estimate the area under the curve by plotting V from 4 to 8. So area, as we've seen, it is a half ends plus twice mid loose from what we've been getting from the trapezium rule. So you'll take this one as y0, y1, y2, y3, y4. So the ends are the ordinates for y0 and y4. So I'll come and take, I've actually got the value. There it is 5. So it will be a half into y0 plus y4 plus twice y1, y2, y3. y1 plus y2 plus y3. But those points for y, you'll use the points for pressure. You are using the points for pressure. So you'll come and have a half. Y0 is 5. Y4 is 2.5, as seen there. Then plus twice y1 was 4, y2 3.3, and y3 is 2.86. Those are the values you get. So you'll come here, it is 1 over 2 into 7.5 plus twice into, add the whole numbers. 4 plus 3, 7. 7 plus 2, 9. So you'll get 9. Add the decimals, 0.33 plus 0.86. You'll get 1.19. 1.19. So still works to a half into 7.5 plus, this will work to 10. 9 plus 1 is 10 into twice 10.19. It works to that. So this will be a half times 7.5 plus 20.38. 20.5 plus 20.38. So it comes to 27.88, which is 27.88 divided by 2, which will give 13.94 square units. So Lana, it gives 13.94 square units. So look how the points were plotted, and they said use 4 equal intervals. So those were the strips. So from there, we plotted the graph. We used our formula ends and mid-loos. Mid-loos are the mid-loo ordinates. Ends are the first and the last ordinates. So having worked out that, it is always to do more practice to make you perfect. That's why we are going to the question in the assignment. Quickly. So sorry, before we continue, there was our H. This H. So you are supposed to include it here, times 1, but it eventually cancels. So it's good to write a half H. So H is actually equal to 1 unit. H is equal to 1 unit. So it eventually cancels out. So it is the strip width. H is the strip width, the width of that strip. So for the assignment, quickly, during a survey, so quickly through the question for the assignment. During a survey, offsets were taken at intervals on a side along a straight line PQ. It was a straight line which cut off the irregular side of a piece of land. It cut off the irregular side of a piece of land. The table below shows the perpendicular offsets at different intervals along PQ. Use the trapezium rule to estimate the area of the irregular portion of land, the irregular portion of land. So you'll be forced to plot that. You'll be forced to plot that with this on the x-axis and that on the y-axis. So it will traject something like a curve, and you'll use the trapezium rule to calculate the area of the land in square meters. So thank you very much, and get more practice as you work out that question. It's going to be healthy for your continuous practice and assessment of whether you've got the concept on trapezium rule. So thank you very much, and let's meet with great agility in the next lesson. Bye-bye.